Hello. In this lesson, I want you to graph transformations of the sine and cosine functions. I want you to use sinusoidal functions to solve problems. Some vocabulary you're going to come across is sinusoid, amplitude, frequency, phase shift, vertical shift, and midline. Here's a review of from Algebra 2 when you graphed sine and cosine functions. The sine function starts at 0 and has a period of 2 pi. On this graph, we have two periods. It goes from negative 2 pi to positive 2 pi. We like that a lot. The amplitude, that is the distance from the midpoint to the top, is 1. That's also the midline of your function. It's continuous. It's not increasing or decreasing because it keeps on changing each time. But it has a maximum at 1 and a minimum at negative 1. There is no end behavior because it keeps on oscillating between negative 1 and 1. Cosine is just a phase shift of pi over 2 from your sine function. In other words, you start at 1 and we go down. That's usually how we're going to graph that. Now, what we're going to look at is what do you do to transform this? It's going to follow the formula y equals a. I want that a little bit thicker for you. And I don't like pink either. Y equals a times sine of bx plus c plus d. Or cosine of y equals a times the cosine of bx plus c plus d. We're going to look at each one of these and see what does this do to your function. We're going to start with a, the amplitude. So when you have a function and you multiply it by something, the only thing you do is you change the amplitude. So in this one, on example 1, your amplitude is 2.5. That's a in our formula. Let me write that down here. Y equals a sine of bx plus c plus d. So now what we're going to do is we're just going to graph this function like you did in Algebra 1. I know my graph goes from negative 2 pi to positive 2 pi. So usually we count by pi over 2. So here's negative pi over 2, pi, negative 3 pi over 2. That was a negative pi, by the way. And negative 2 pi. I'm just going to graph my quadrant angles. Then 0. And then pi over 2. Got an extra tick mark there. I don't like that. Positive pi, 3 pi over 2, and 2 pi. So my straight sine function, I'm going to graph f of x equals sine x in pink. So it starts at 0. It goes up to 1. Back to 0, down to negative 1, and then up there. And I should put a 1 here. And I'll do the same thing going backwards. It goes down to negative 1, up to 0, up to 1, if I can, and then down to 2 pi. Well, with an amplitude of 2.5, I'll put that in purple. So here's 2, and here's 2.5. There's 1, 2.5. So in other words, my maximum are going to be at positive 2.5 and negative 2.5. The rest of the graph stays the same. It still crosses and goes back up, down and up and back down. Now, I'm not very good at drawing. You can tell that. My handwriting isn't very good, so if I try to draw it, it gets even worse. We're going to use Desmos to show you this, and you can use Desmos to check, but Eventually, you're going to have some problems that you have to understand what's going on. So use Desmos to check, not to cheat and do the problems. Here you can see I've graphed y equals sine x and y equals 2.5 sine x. See how the amplitude just changed 2.5? Nothing else changed there. Now let's take a look at example 2. On example 2, we've got cosine x, and we've got negative 2 cosine x. So I'm going to find the amplitude and sketch 2 periods of both functions on the same coordinate plane. So I know what's going to happen. My amplitude is now going to be 2. But that negative sign makes it flip over the x-axis. So it's a reflection over the x-axis. So once again, I'm going to just draw my graph. I should have posted a graph on here, so it saved us some boring time in watching me write this in here. So 0, pi, and 2 tick marks again. I don't like why it does that. Pi over 2, pi, 3 pi over 2, and 2 pi. So I know I'm going to go up to 1. I'm going to put my 1 on here right away. And then negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. I know I'm going to start at 1 for cosine. So I'm going to go down through 0, down to negative 1, back up to 0, and up to positive 1. I'll do the same thing going backwards. Except it's supposed to be a nice, clear graph. Now, I'm going to, in purple, I'm going to make negative 2 cosine x. So I'm going to go up and down to 2, but I'm going to flip them. So instead of being at 1, I'm down here at negative 2. My zeros are still the same. Then I'll be up at positive 2, 0, and down here again. So here's 1 period. And then I'll do the same thing here. There's 2 periods. And there's your answer. And once again, let's look at a nice function. So I'm going to undo the sine. There's cosine. And there's negative 2 cosine x. I think I like looking at the Desmos one a little bit nicer to see that. But I also wanted to show, I think on future ones, I'm just going to go straight to Desmos so you can see it, how it looks nice graphed. But you will have to do some of the graphing by hand on your assignment.